Hello, my dear friends. How are you all? I hope you all are fine. So, my dear friends, you are very welcome in a lecture number 6 of triangles. Okay. So, today we are going to discuss amazing and new topic. So, you have to listen very carefully. Okay. So, let's start without wasting the time. Yes. So, today we are going to discuss inequalities in a triangle. Inequalities in a triangle. Okay. Now, in this we are going to discuss theorem 7.6. Okay, now the theorem 7.6 states that if two sides of a triangle are unequal, if two sides of a triangle are unequal, the angle opposite to the longer side, the angle opposite to the longer side is larger or greater. Means, let's suppose we have a triangle ABC. Okay, and in this here is AB is greater than AC. Okay, AB, this line AB is greater than AC. So the angle opposite to the longer side means this is a longer side, and angle opposite to this side means this angle. We are talking about this angle. We are talking about this angle. Okay, so it is. So it is means, so this angle is larger. Okay, this angle is larger. Okay, I hope you get this point. So now, so let's prove this theorem. Here is, first of all, we are going to write the given path. Here, what is the given path? Triangle ABC such that AB is greater than AC. AB is greater than AC. Okay, and we have to prove angle C is greater than angle B. We have to prove this angle is greater than angle B. Okay, so first of all we have to do a construction. Okay, we have to do a construction. So what is the construction? So here is, now take a point P on side AB. Means on this side we have a triangle ABC. We are taking P point on AB such that AP is equals to AC, such that AP is equals to AC. Okay, and join CP, and join CP. Okay, so in the construction we are taking a point P on AB, on AB such that AP is equals to AC, and then join CP. So I hope you understand these things. Now let angle APC is X. Angle APC is X, and if this angle is X, so this angle is also X, because here is we have two sides are equal. Two sides are what? Two sides are equal. Okay, so angle opposite to the equal sides are equal. Okay, and now we are assuming this angle BCP is Y. We are assuming this angle is Y. So now here is, let angle APC is X degree and angle BCP is Y degree. Okay, my dear friends, I hope you get this point. So from this we can write as angle APC is equals to angle ACP. Okay, by the theorem, by the theorem 7.2. What is the theorem 7.2? Angles opposite to equal sides are equal. Angles opposite to equal sides are equal. are equal. So I hope you get this point. So here is angle ACP is what? Angle ACP is also x degree. Is also x degree. I hope you get this point. Okay, so now on line AB, means on this line AB, we know that here is this angle x plus angle BPC, means this angle, they form linear pair. Okay, so this will become, here is on line AB angle APC plus angle BPC is equals to 180 degree, because linear pair. Got it? So we know that angle BPC will become, here is, if we shift angle APC to the RHS, we get minus angle APC. So we know that angle APC is what? Angle APC is x degree. Okay, so angle BPC will become 180 minus x degree. So this is, let's suppose this is equation number 1. Okay, so angle BPC is what? 180 degree minus x. 180 degree minus x. Okay, now in triangle PBC, in triangle PBC, we know that sum of all interior angles is 180 degree. So we can write here as, in triangle BPC, angle BPC plus angle PBC plus angle PCB is equals to 180 degree. Okay, angle BPC, we know that this is 180 minus x, 180 degree minus x plus, okay, we don't know the value of angle PBC, so this is same as plus angle, and we are supposing angle PYC is y degree, so this is y is equals to 180 degree. Okay, so angle PBC will become, here is, you can see that 180 degree and this 180 degree will be cancelled. So we get x minus y. Okay, so this is what, this is angle B. So we can write also angle B is equals to x minus y. So we have angle B is what? X minus y. Okay, and we know that angle C is what? X plus y. Angle C is x plus y, and angle C is x plus y. Okay, so now from this condition, if you observe this angle B and angle C, we can say that angle C is greater than angle B. Okay, because here is, you can see, here is x minus y, means this angle is decreased, and here is x plus y, it means this angle is increased. So we can say, so from above condition, we can say that angle C is greater than angle B. Angle C is greater than angle B. So hence proof. So similarly, we can also prove that, we can say that if AB is greater than BC, here is the case of what? Here we are taking AB is greater than AC, so angle C is greater than angle B. If we are taking AB is greater than BC, then we can say angle C is greater than angle A. Okay, so this is also, we can prove that in this, if we are taking AB is greater than BC. Okay, so take the point Q on AB such that BQ is equals to BC. Okay, and similarly we can prove that angle C is greater than angle A. Again we can repeat the same procedure as we follow in the previous theorem, in the previous proof. Okay, this theorem, this process we can again repeat. Okay, and we can prove that. Okay, so take point Q on AB such that BQ is equals to BC. Okay, and then we can prove angle C is greater than angle A. Okay, so we can write hence proved. So I hope you understand these things, my dear friends. Okay, so this is the theorem, this is the proof of this theorem. Okay, so what is the theorem? If two sides of a triangle are unequal, then the angle opposite to the longer side is larger. Angle opposite to the longer side is larger. It means if AB is greater than both from both AC and BC, then we can say that angle C is greater than from angle A as well angle B. Okay, means angle C is greater than both angle A and angle B. So this is the main concept of this theorem. Yes, so I hope you understand these things, my dear friends. So now let's move on to the next theorem, which is now theorem 7.7. So this theorem states that in any triangle, the side opposite to the larger angle or greater angle is longer. So means basically it is the converse of the previous theorem. It is the converse of the previous theorem. So it is saying that, let's suppose we have this larger angle. So this is larger angle. Okay, and according to this theorem, the opposite side to this larger angle is greater, is larger, or is longer. Okay, I hope you get this point. So here is we have the given as triangle ABC. We have a triangle ABC such that angle C is greater than angle B. Okay, we are taking angle C is greater than angle B. Okay, so we have to prove AB is greater than AC. Okay, if we are taking angle C is greater than angle A, then we have to prove AB is greater than BC. Okay, my dear friends. Yes, so now let's start to prove this. So let us assume that AC, okay, we are assuming that AC is greater than AB. This is our assumption. Assume, okay, assume AC is greater than AB. So we can write then angle B is greater than angle C. Means here is we are taking AC is greater than AB. Means angle opposite to the larger side is greater, so we can say angle B is greater than angle C. So this condition is what, this is by previous theorem, by theorem 7.6, because it is saying that if two sides of a triangle are unequal, then the angle opposite to the longer side is greater, is larger. Okay, got it? So now here is, so this contradicts our assumption. Okay, because we have angle C is greater than angle B. Okay, and this condition is contradicts our assumption, so we can say that given part is contradicts our assumption. So we can say that AB is greater than AC. AB is greater than AC. So we can write hence proof. We can write what? We can write hence proof. So I hope you understand this thing. So this is the theorem 7.7. Okay, and this is the proof of this theorem. Okay, I hope you get this point. So now let's move on. Yeah, so now let's come on the theorem 7.8. Okay, so this theorem states that the sum of any two sides of a triangle, is greater than the third side. Okay, this is the property of a triangle also. Okay, so we have to prove this theorem. Okay, so now let's suppose we have a triangle ABC. We have a triangle ABC. Okay, and we have to prove that the sum of any of the two sides is greater than the third side. Now let's suppose we have to prove, like we are taking AB plus AC. Okay, AB plus AC, and the sum of these two sides is greater than BC. Okay, we can take AB plus BC, so the sum of these two sides is greater than AC. We can take AC plus BC, and the sum of these two sides is greater than AB. Okay, and we are taking AB plus AC, which is greater than BC. Okay, so now in this we have to do a construction. Okay, so like this, here is a construction. So what is the construction? You can see that now we are extending AB. We are extending AB to point D such that AD is equals to AC. AD is equals to AC. Okay, here is extend AB to D such that AD is equals to AC. Got it? So now here is, let's start to prove this. So now in triangle ACD, means in this triangle AD is equals to AC. We can write by construction. Okay, so we can say that this angle 1 is equals to angle 2 by the theorem. So angle 1 is equals to angle 2, because we know that angles opposite to equal sides are equal. Are equal. I hope you get this point. So angle 1 is equals to angle 2. Okay, now my dear friends, here is angle BCD, means this angle is what? Angle BCA plus angle 1. Angle BCA plus angle 1. We know that angle BCD is equals to angle BCA plus angle 1, and we know angle 1 is equals to angle 2, so we can write here as angle BCA plus angle 2. Okay, so angle BCA plus angle 2, because we know that angle 1 is equals to angle 2. Okay, I hope you get this point. So we can say that angle BCD means this angle is greater than 2 from this condition. So we can write angle BCD is greater than angle 2. Now in triangle, here is, you can see that in triangle BCD, here is angle BCD is greater than angle 2. So you can see that we know that if here is this angle is what? Angle BCD is the larger angle, according to this is the larger angle. So we can say that BD is greater than BC. By the previous theorems. Okay, I hope you get this point. So now we can write here as BD is greater than BC. So by theorem 7.7, side opposite to the larger angle is longer. Larger angle is longer. Okay, my dear friends. So now here is we can write as AB plus AD. Here is BD is what? BD is, we know that AB plus AD, which is greater than BC. Okay, and we know AD is what? AC. AD is what? AD is AC. So we can write here as AB plus AC is greater than BC. We can write AD is equals to AC. So hence proof. So we can say the sum of two sides AB plus AC is always greater than the third side, which is BC. Hence proof. Okay, and similarly we can also prove AB plus BC is greater than AC. Means this line AB plus BC is greater than AC. Or we can prove also and AC plus BC is greater than AB. Means AC plus BC is greater than AB. So this is the theorem 7.8. What is the theorem? If we sum any of the two sides of a triangle, so the sum of any two sides of a triangle is always greater than the third side. Is always greater than the third side. So I hope you understand these things. So now let's solve the problem. Okay. So now in the question number 1, show that in a right angle triangle, the hypotenuse is the longest side. The hypotenuse is the longest side. Okay. Okay. So now my dear friend, we know that ABC is a triangle. Okay, is a triangle, and ABC is what? ABC is a right angle triangle and right angles at A. Okay, here is the 90-degree angle. So we know that angle A plus angle B plus angle C is equals to 180 degree by angle sum property. Okay, now here is, we know that angle A is 90 degrees, so angle B plus angle C is equals to 180 minus 90. So this will become angle B plus angle C is equals to 90 degree, because we know that angle A is what? 90 degree. Angle A is 90 degree. So angle B plus angle C is 90 degree. Okay, so it means angle A is larger angle of the triangle. Means we can say, so angle A is larger angle of triangle ABC. Okay, so we can say the side opposite to it must be larger. So here is, means we can say BC, which is what? Which is a hypotenuse, is largest, is longer. Okay, I hope you get this point. So angle A is larger angle of triangle ABC. So we know that, so this side opposite to it must be the largest. Okay, so we know that AB is a hypotenuse. AB is hypotenuse. So which will be be the largest side, which will be the largest side of the right angle triangle, of the right angle triangle ABC. Okay, I hope you get this point. So this is by theorem. Which theorem? By theorem 7.7. Okay, understand my dear friend, this is the answer. Okay, so we know that the side opposite to the larger angle is always the largest side. So now let's move on to the next question, which is, now in figure, side AB and AC of triangle ABC. Okay, we have a triangle ABC. Okay, and the side AB are extended to point P and side AC are extended to point Q respectively. So also angle PBC is greater than angle QCB. Now we have to prove, we have to show that AC is greater than AB. AC is greater than AB. I hope you understand these things. So it is given that angle PBC is less than angle QCB. Okay, and we know that angle ABC, here is angle ABC means this angle plus this angle PBC is 180 degree because of linear pair. So angle ABC plus angle PBC is 180 degree. This is linear pair. This is what? This is linear pair. Also angle ACB means this angle plus angle QCB means this angle is equals to 180 degree. Again same reason, linear pair. Okay, so from this condition, from the first equation, we can write angle ABC is equals to 180 degree minus angle PBC. Okay, this condition is from this equation. Okay, and here is angle ACB is equals to 180 degree minus angle QCB. Okay, angle QCB. So from this we can say that here is, we know that angle PBC is less than angle QCB, means we can say that this term is larger than this term. Okay, because here is angle QCB is greater than angle PBC. Okay, my dear friends. So we can understand this condition like this. Here is, if we subtract 180 minus, let's suppose here is, we are taking angle PBC is, let's suppose, this is supposing, we are supposing that angle PBC is 10 degree. So this is 170 degree. Okay, and 180 degree minus, let's suppose this is angle QCB is greater than PBC. So we are taking, let's suppose this is 20 degree. We are taking this is 20 degree. So this is what? 160 degree. So from these two terms, in the out of these two terms, which one is greater? 170 is greater than. So we can say that angle ABC is greater than angle ACB. Okay, so we can say that angle ABC is greater than angle ACB. Okay, angle ACB. Okay, so now here is, now angle ABC is greater, then we can say AC side is larger, and angle C, angle ACB is smaller than AB side is smaller. Okay, so we can write by the theorem. So AC is greater than AB, as we know that as sides opposite to the larger angle is always larger. Okay, we can write hence proof. Okay, so I hope you understand these things. So this is the concept of this question. Okay, yes. So now the next question is, now in figure angle B is less than angle A. In this figure angle B is less than angle A and angle C is less than angle D, means this angle is less than angle D, and show that AD is this. AD is less than BC. AD is less than BC. Okay, so how we can prove this? So in the question it is mentioned that angle B and angle C is smaller than angle A and angle D respectively. Okay, that is, we know that angle B is less than angle A, and angle C is less than angle D. Got it? So my dear friends, since we know that the side opposite to the larger angle is always larger and side opposite to the smaller angle is always smaller. Okay, and we know that here is angle B is smaller than angle A. It means OB line. It means OB is greater than OA. So from this condition we can write OB is greater than OA. So this is equation number 1. Okay, and similarly we know that angle D is larger than angle C. So we can say OC is greater than OD. So OC is greater than OD. So this is the second condition. Okay, so now by adding these two conditions, now if we add equation 1 and equation 2, we get here is, if we add OB plus OC is greater than OA plus OD. Here is OB is what? OB plus OC is BC is greater than OA plus OD is AD. Okay, so we can say that we can write AD is smaller than BC. AD is smaller than BC. Hence proof. I hope you understand these things. So now let's move on to the next question, which is, now AB and CD are respectively the smallest and longest side of a quadrilateral ABCD. AB and CD. Okay, so AB is smaller than CD. This line CD. AB and CD. So AB is smaller than CD. Okay. Now show that angle A is greater than angle C. Means we have to prove angle A is greater than angle C. And angle B is greater than angle D. Means this angle and this angle. Okay. So here for solving this, for proving this, we have to do a construction, like we have to join B to D and A to C. B to D and A to C. Okay. So in triangle A B D, means in triangle A B D. Okay. here is AB is less than AD, is less than AD, we can see that, and which is less than BD, means BD is the largest side. BD is the largest side. So we can write here is angle ADB is, means angle ADB means this angle is less than angle ABD. Angle ABD means this angle. Okay, because we know that this is, let's suppose this is equation 1, and reason is what? The reason is angle opposite to the longer side is always longer, is always longer. Okay, you can see that we know that AB is smaller than AD, is smaller than AD. Okay, so this angle is what? This angle is smaller than angle ABD from this angle. Okay, now in triangle, in which triangle? In triangle BCD, means this whole triangle BCD. Okay, so here is, we can write as, you can see that BC is less than DC, means BC is less than DC. Okay, so it can be concluded that angle BDC means angle BDC means this angle is less than angle CBD, is less than angle CBD means this angle. Again, this reason is same, angle opposite to longer side is always longer. Okay, because here is, you can see that BC is smaller than DC, and DC is what? DC is larger. So so the angle opposite this side is what? This angle. So this angle CBD is greater than angle BDC, means this angle. Okay, so now here is, this is equation second. Now add equation first and second. So we get, add equation first and equation second. Okay, so we get what? We get, if we had angle ADB, this angle ADB plus angle BDC plus angle BDC and is less than angle ABD plus angle CBD. Okay, so we get, if we add, you can see that if we add angle ABD and angle ADB, means angle ADB and angle BDC, means if we add this angle and this angle, we get this complete angle, means angle D. Okay, we get what? Angle D. We get angle D. Okay, which is less than, it is less than. Now if we add angle ABD plus angle CBD, angle ABD means if we add this angle and angle CBD means if we add this angle, so we get angle B. We get angle B. So here we get angle B. Okay, so this condition is hence proved. So we have to prove what? We have to prove angle. Yes, here is angle B is greater than angle D, and according to this statement, angle B is greater than angle D, or we can say angle D is less than angle B. Okay, now again we have to prove angle A is, yes, angle A is greater than angle C. So for this we have to take triangle ABC and triangle ADC. Okay, we have to take these two triangles. So now similarly in triangle ADC, okay, you can see that, we know that, you can see here is, we know that DC this line DC is larger than this line AD. Okay, so angle DCA means this angle is, okay, is less than angle DAC means this angle is less than angle DAC. So here we can write as, we know that DC is greater than DA. Okay, so we can write angle DAC is greater than angle DCM. Okay, so this is a third equation. Okay, and in triangle ABC, okay, in triangle ABC, here is in triangle ABC, we know that you can see in the figure, in this triangle ABC, here is BC, this line BC is greater than AB, so this angle is greater than this angle, so we can write, here is BC is greater than AB. BC is greater than AB. So angle BAC is greater than angle ACB. Means angle BAC is greater than angle ACB. Okay, angle ACB. So now this is the equation number 4. Now add equation 3rd and equation 4th. Okay, we are adding equation 3rd and equation 4th. Okay, so what is the equation 3rd? Which is angle DAC. Now if we add angle DAC and we have to add angle BAC, angle DAC plus angle BAC, okay, is greater than, we are adding angle ACB plus angle DCA, means this angle DCA plus angle ACB. So you can see in the diagram, if we add angle BAC means angle BAC plus angle DAC, means if we add this angle and this angle, then we get angle A. We get what? We get angle A. So this is angle A greater than, and if we add angle ACB plus angle DCM, if we add angle, here is ACB and DCA, means if we add this angle and this angle, we get angle C. We get what? We get angle C. So we can write hence proof. So we can write what? We can write hence proof. So I hope you understand these things, my dear friends. So now let's move on to the next question, which is, now in figure PR is greater than PQ. PR is greater than PQ and PS bisect angle QPR. PS bisect angle QPR, means this angle, yes, means we have to prove angle PSR, means angle PSR is greater than angle PSQ. PSQ, okay, means we have to prove this angle is greater than this angle. I hope you get this point, my dear friends. Here is, so it is given that PR is greater than PQ, okay, and PS bisect angle QPR, okay, and we will have to prove that angle PSR means we have to prove angle PSR is greater than angle PSQ. Is greater than what? Angle PSQ. Okay, so now here is, we can write as angle QPS is equal to angle RPS. Angle QPS means this angle is equal to angle RPS, means this angle. Okay, because here is as P as bisect angle QPR. So we can say this angle is equal to this angle. So this is what, this is equation number 1. Okay, now angle PQR is greater than angle PRQ. This angle PQR, this angle is greater than this angle, because here is we have PR is greater than PQ. So the angle opposite to the larger side, so PR is larger side, so this angle is greater than this angle. Got it? So here we can write as the reason, since we know that PR is greater than PQ, PR is greater than PQ. Okay, as angle opposite to the larger side is always larger. Okay, I hope you get this point. So this is equation 2nd. Okay, this is equation 2nd. And now, so now here is, we know that angle PSR means this angle, okay, is equals to what, is equals to angle PQR, okay, plus angle QPS means this angle, means this is what, this is the exterior angle of triangle PQS. So this is equals to the sum of the opposite interior angles, means this angle is equals to this angle plus this angle. Okay, so here we can write as angle PSR is equals to angle PQR plus angle QPS. So this is the third equation, and the reason is, since the exterior angle of a triangle equal to the sum of opposite interior angles. Got it? And similarly we can write as angle PSQ, means this angle is exterior angle for triangle PSR. So we can write angle PSQ, means this angle is equals to angle PRQ means this angle, plus angle RPS means this angle. Okay, again we can write as angle PSQ is equals to angle PRQ plus angle RPS. So this is equation 4, and the reason is same as like this. Okay, so the reason is same. So now we are adding, now add equation 1 and equation 2. Here is this equation 1 and equation 2. So we get what we get. Here is angle PQR plus angle QPS is greater than angle PRQ plus angle RPS. Means we add angle, yes, angle PQR plus angle QPS is greater than what? Angle PRQ plus angle RPS. Okay, so now from equation, here is from equation 2nd and 4th. If you see in this equation 2nd and 4th, here is angle PQR plus angle QPS, okay, which is what, angle PSR, angle PRQ plus angle RPS, which is equals to angle PSQ. So you can see that angle PQR plus angle QPS means this equation, this side is greater than angle PRQ plus angle RPS, means this side. Okay, so we can write angle PSR is greater than angle PSQ. Angle PSR is greater than angle PSQ. So from third and fourth, angle PSR is greater than angle PSQ. Hence proof. So this is hence proof. So I hope you understand these things, my dear friends. Okay, so this is the required result. Angle PSR is greater than angle PSQ, and here is angle PSR is greater than angle PSQ. Okay, so I hope you understand these things, my dear friends. So now let's move on to the next question, which is now show that of all line segments drawn from a given point, not on it, the perpendicular line is the shortest. So now here, first of all, we have line L. Okay, L be a line segment, and B be a point lie on line L. Okay, now a line AB is perpendicular. We are drawing a line AB which is perpendicular to L. It is perpendicular to L, and let C be any point on L. So we are taking point C on L. Okay, and we have to join AC. Okay, and here is we have to prove AB is less than AC. AB is less than AC. So now in triangle ABC, here is angle B is equals to 90 degree. Angle B is what? 90 degree. And we know that angle A plus angle B plus angle C is equals to 180 degree. What is 180 degree? So angle A plus angle C is equals to 180 minus 90, because angle B is 90 degree. So this will become 90 degree. So angle A plus angle C is equals to 90 degree. Okay. Now here angle C must be an acute angle, which implies that here angle C must be an acute angle, so that angle C is less than angle B. Angle C, yes, here is angle C is less than angle B, and so that we can say that AB is less than AC. This is AB is less than AC, because angle C is what? Angle C is less than, smaller. Okay, so the side opposite to the smaller angle is smaller. Okay, so we can write the reason as the side opposite to the side opposite the smaller angle is smaller. Okay, so AB is smaller, AB is less than AC. So it means we can say that, yes, we can say that hence proof. So this is hence proof. Okay, so I hope you understand these things, my dear friend. So this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.